Okay, here we go. Magnetic fields and forces. You know, I still get the same problems, the same questions when people come to these problems because we're not following the fundamentals of our physics, which is before you even ask a question, write down what you have. So let's do that before we even worry about the question. Let's write down what we have. I see wire 0.1 meters long. So we have our displacement. In this case, we'll just say length. So off to the side, we're going to say length equals 0.1 meters. Next, carrying a current. Well, current is I, and it's 2 amps. So our current equals 2 amps. I'm just going to put 2 for that. Well, we'll just put amps, whatever. All right, and lastly, is at a right angle to the magnetic field. The force on the wire is 0.04 newtons. So force equals 0.04 newtons. So I have my length, my current, and my force right off the bat. I haven't even asked a question yet, but I have those three. Next, what is the strength of the magnetic field? Well, that's B, right? B equals, and I'm going to leave blank. So now I have 4 things, one of which is unknown. And now I'm going to worry about, okay, how do I do this? Because asking how do I do this before I even write this down is pointless, a waste of my time, right? I'm not going to worry about the second question yet because I'm focused on the first. Worry about the second after we do the first. So, what is the strength of the magnetic field? So, here's the deal. We got to be problem solvers. Am I going to ask how to do this, or am I going to try and figure it out? So I have these. So I'm going to look for a formula that has length, current, force, and field. So if I turn back one page, I can see right here, bam, force, current, length, field. Wow, that's exactly what I needed. So I didn't even have to ask a question, bam. Sometimes you do, nothing wrong with asking a question. Oh, I forgot to take this ladybug thing. This thing is annoying. Get off my screen. There we go. So let's write down my formula. Next, force equals current times length times field. Okay. Now let's plug it in. My force was 0.04. My current was 2. Parentheses. My length was 0.1. Parentheses. And my magnetic field was, we don't know. So it looks like this, right? Because we knew the force, but we didn't know this. So once you've solved this, this is easy. 2 times this, dividing into that 0.04, that should give us a field of 0.2, and then magnetic field is in Teslas, so it's Teslas, right? So I'm going to box that because my first one's done. Now I need to do the second one. So I've done the first one, that's a check. Now I'm doing the second one. What would the strength be if the wire was at an angle of 35 degrees? So all I'm going to do for that one, if I'm going to use a field with a angle, this would be my formula. Force equals current times length times field times the sine of the angle. In this case, I've already done all this stuff, so all I got to do is take my B and do 0.2 times sine of 35. Now this can get weird because sometimes, especially the calculators, the new ones, they have all these different functions, and they could give you one answer if it's on radian mode, one answer if it's on degree mode, so make sure we're set up for that one. So I'm going to do it. 0.2 times, mine just, it puts the X in because it's like a phone calculator, but that's fine. Yours, you'll just put it in parentheses. Sine 35, close parentheses, boom. So if we are looking at the second question, what would the strength be if the wire is at an angle of 35 degrees? It is going to be the field equals 0.11 Teslas. So that was pretty easy, pretty straightforward, right? All right, let us move on to number 2. Same deal. Before I even think, I'm going to write down what I got. I have length, 0.5. I know that's current because I see amps. Current equals 8. It's at an angle of 15 degrees. And so I'm just going to say, I'm going to put that a little lower. Angle equals 15. And my field equals 0.4 teslas. What is the magnetic force? Cool, so this is our standard formula. So I'm going to write the formula again. F equals ILB. And then if we're going to do the angle, we're just going to put sine of angle. That's like sine angle, right? So now let's plug it all in. Force, we don't know, equals 8 times 0.5 times 0.4, right? 0.4, 0.5, 8, and then sine of 15. What is the magnetic force exerted on the wire? All right, cool. So let's plug it in and see what we get. That's my last one. I'm going to clear that. So I'm going to do 8 times 0.5. You're just going to do 8 in parentheses, open parentheses back up 0.5 on your calculator, open the parentheses back up 0.4. Mine, because it's a phone, I don't have that. I guess I could, but this works, so that's what I'm going to do. Sine 15, close, and I should get, bam. So my answer is, my force, we know it's going to be in newtons, is going to be 0.414. There we go. 1 and 2 are done. All right. Good job, guys. I'll make a new video for 3 and 4 just so we're not like super long videos.